Ibu Yuli. Yang kami hormati Ketua Program Studi Magister Manajemen Wilayah Pesisir dan Laut, Bapak Dr. Supono SPI MSI. Yang kami hormati Ketua Program Studi Doktor dan Magister di lingkungan Pascasarjana Universitas Lampung yang kami hormati, para dosen, mahasiswa, dan peserta kuliah umum sekalian. Kami ucapkan selamat datang dan selamat bergabung. Puji syukur marilah kita panjatkan kehadirat Allah Subhanahu wa Ta'ala, karena berkat rahmat dan karunia jualah kita dapat berkumpul pada hari ini, hari Senin tanggal 11 Juli 2022 di Pascasarjana Universitas Lampung dalam acara Kuliah Tamu dengan tema Physical Processes Impact on Harmful dinoflagellates bloom in Hurun Bay, First Result and Perspective. Bapak Ibu yang kami hormati, marilah kita buka acara ini dengan sama-sama membacakan lafaz basmalah. Acara selanjutnya adalah sambutan dari Direktur Pascasarjana Universitas Lampung yang sekaligus membuka acara kita pada pagi hari ini. Kepada Bapak Profesor Dr. Ahmad Sauri Samosir STMT, dipersilahkan.
Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati narasumber Rianis Kuiper, PhD, perwakilan dari Balai Besar Perikanan Budidaya Laut, BPL Lampung, Wakil Direktur Pascasarjana, para ketua program studi, dan para peserta kuliah tamu hari ini yang baik hadir secara offline maupun secara online. Alhamdulillah hari ini kita bisa bertemu dalam acara kuliah tamu yang diselenggarakan oleh program studi Magister Manajemen Wilayah Pesisir dan Laut. Program Pascasarjana Universitas Lampung yang bekerja sama dengan Balai Besar Perikanan Budidaya Laut. PBL Lampung. Ketika kuliah tamu ataupun seminar merupakan kegiatan rutin yang dilakukan oleh program studi yang ada di Pascasarjana Universitas Lampung sebagai upaya untuk meningkatkan iklim akademik di lingkungan pascasarjana. Hari ini kita beruntung sekali dapat menghadirkan pembicara ahli dalam bidang kelautan yang dari Sorbonne University Prancis, yaitu Dr. Rianis Kuiper, PhD. Semoga acara ini bisa berjalan dengan baik dan kita dapat mengambil manfaat yang sebesar-besarnya dari kegiatan ini. Saya mengucapkan terima kasih pada narasumber Rianis Kuiper, PhD, atas kesediaannya menyampaikan materi dan instansi Balai Besar Perikanan Budidaya Laut PBL Lampung. Serta terima kasih kepada semua pihak yang telah membantu terselenggaranya kegiatan ini dengan berjalan dengan baik. Selanjutnya, tanpa berpanjang kata, dengan ini acara kuliah tamu program studi manajemen wilayah pesisir dan laut hari ini dengan resmi saya buka. Wabillahi taufik walhidayah. Assalamualaikum warahmatullahi wabarakatuh.
foto bersama, dimohonkan kepada peserta yang hadir secara offline untuk secara online untuk menghidupkan kameranya karena kita akan melakukan sesi foto bersama. Belum. Ke depan cukup.
Semuanya berdiri ya. Bareng di online. Kurang Indonesia aja tuh.
Oke. Hadirin sekalian, tibalah kita pada acara inti pada hari ini, yaitu penyampaian materi
Terima kasih. Terima kasih. Suara saya sudah terdengar? Ya, baik. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Oke, ini juga. Oh gitu. Oke. Sekali lagi, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Oke, terima kasih. Hari ini kita akan melaksanakan kuliah tamu dengan sebagai narasumber adalah tadi sudah disampaikan adalah Dr. Yanis Kupres. Dan sebelum itu saya akan menyampaikan CV beliau. Beliau adalah staf dosen dari Sorbonne University dan juga sebagai co-leader dari Proteo Team, Pro-Casus in the Detection Divine and Oceanic. Maaf kalau pronunciation bahasa Perancis saya kurang jelas. Education dari beliau adalah beliau fellow postdoc di LSU INPC di bidang internal wave and mixing in subalpine lake impact in cyanobacteria distribution pada November 2004 sampai Agustus 2006. Beliau menyelesaikan PhD di Fluid Dynamic and Transfer University Paris dan juga Dennis Detroit in Paris, PMMH Laboratory, dan juga research interest dari beliau adalah high frequency dynamic in ocean, internal waves and turbulent mixing, impact on the biogeochemical dynamic. Expertise beliau adalah fine scale physical oceanography, in the field of observation, turbulence signal processing, turbulence parameterization, high resolution ideal simulation. Current project yang beliau miliki sekarang ini adalah leader dari PALHADIN, yaitu Physical Process Impact on Harmful Dinoflagellate Bloom, dari AAP Changement Climatic CNR EFI IRAD. Beliau juga sebagai memiliki proyek di BioSWOT, paving the way of the exploitation of SWOT observation for the understanding of fine scale biophysical processing, CNSA, NNR. Beliau juga punya proyek di SOLAB Interaction, Planetoquick. Di samping itu juga beliau punya proyek di Tonga Shallow Hydrothermal source of trace element. Berikut adalah CV dari beliau. Yang utama sekali adalah beliau mempunyai publikasi yang cukup tinggi dengan high index di Scopus adalah 12. Beberapa publikasi yang terkenal yang ada adalah dari Progress in Oceanography dan juga dari Journal of Physical Oceanography, as well as Progress in Oceanography, as well as Geophysical Research Letters. Baik, Bapak dan Ibu sekalian bisa melihat CV beliau. Untuk itu kita akan mendengarkan paparan dari beliau. Nanti saya akan coba untuk jika ada pertanyaan, silakan Bapak dan Ibu sekalian untuk mengisi di chat room. Untuk adik-adik yang secara offline, silakan nanti bertanya secara langsung. Kalaupun tidak merasa sungkan dengan bahasa Inggris, paksakan saja ya. Nanti saya akan coba untuk menerjemahkannya ya. Don't worry about English, just talk ya. Karena itu yang poin yang utama adalah kita terbiasa dengan mengatakan sesuatu dalam bahasa Inggris walaupun grammarnya tidak baik. Baik, saya persilahkan. Your time is only 1 hour and after that we're going to have the discussion. Time is yours. Slightly.
Thank you very much for inviting me here at the Lampung University for this talk on the impact of physical processes on our like a so this is a new project we have started about 2 years ago, and maybe yes. So this is a really new project, and just maybe as you will hear my presentation of my short CV, I have a background which is rather physical oceanography. I have a PhD in physical oceanography, and I've been working around the globe and here also in Indonesia on physical oceanography processes. But recently,
Thanks for the introduction. I have a background in physical oceanography. I have been in physical processes on ecological dynamics and more specifically on harmful algal thermodynamics. So first, just a brief outline of the talk. I would like to give a small introduction of my laboratory. Then I will try to So my laboratory is l'Océan. It's a laboratoire, oceanography laboratory for climate, which is based on experiments, in-situ experiments.
Coba Pak, tes dulu Pak. Belum Pak, belum. Tes.
Kalau yang ini kedengaran nggak? Ini jelas.
Hello. Okay. So sorry once again. Yes. So I wanted to introduce my laboratory, which is a laboratoire d'océanographie du climat. So it means oceanographic laboratory, climate experiments and numerical approaches. So what is important about our lab is that, as many labs in France, it is a mixed research unit. So there is several supervising organisms. Personally, I am from Sorbonne University, Paris, but there is also, as a supervising organism, we have the CNRS, which is the Centre National for Research, Scientific Research. So it will be here about the equivalent of the LIPI or NARDBRIN. Another important supervising organism of Ocean is IRD, which is a research organism which is focused on the collaboration with countries, notably from the tropical belt. And finally, we have also the Muséum National d'Histoire Naturelle, which is more focused on collections, natural collections. So all these supervising organisms are kind of supervising l'Ocean laboratory. So, for instance, if you would like to sign an MOU, it would be with this supervising organism, where I sign an agreement letter with the l'Ocean unit. So our scientific activities are centered on the ocean. There is a strong component on the physics of the oceans and its interaction with ice and atmospheres. There is also a component which tries to establish the role of ocean on climate variability, past, present, and future, but as well the impact of the ocean on the biogeochemistry, and marine ecosystems. And from all this knowledge, we also try to infer what are the climates, the impacts with climate change, how the climate change will impact our societies. So we have several approaches and methods in this lab. First, we have in situ observations, okay, which are in blue. So we are really based on really in situ measurements. So we can deploy some buoys, for instance. This is what we want to do in Lampung, okay, where we have several set of sensors all along the water column. We can use some AUV like gliders, which are flying on the waters. And of course, we also rely on oceanographic campaign. This is an example here. Okay, but there's also finally a kind of remote sensing observation. For instance, l'Ocean has been really implied, for instance, in the SMOS program. And we also have some specialty on some very specific sensors like turbulence. This is an example of a turbulence sensor. Apart from the observation, we have a strong components on modeling as well. So with one very important model, which is the NEMO model, which is really a numerical implementation of all the physical circulation and a possible coupling with the biochemical processes. And finally, we have analysis platform to analyze chemistry, for instance, CO2 or sediments. And we have recently also some specialties that has been emerging on statistics and big data analysis. So neural networks, deep learning, etc. Okay. The ocean has really global coverage. It's a really large scope belt. So from the polar ocean to the mid latitudes and to the tropical belts, okay, with the specificity IRT. Okay, this was just a general to explain that I cover very with a very large scope of processes with situ measurements to satellite observation. Okay, today I want to first introduce what is the importance of for biological processes. I will try to keep it
Coba dites suara saya kedengaran nggak? Dengar?
Terdengar, tapi ada noise sedikit.
Dengar, Ibu.
Oke. Mungkin dari itunya, dari laptopnya. Coba dia ngomong.
Yes. Okay.
Oke, kami mohon maaf kepada para peserta karena kita ada masalah travel teknis. Dimohon tunggu sebentar. Kita akan memperbaginya terlebih dahulu. Terima kasih.
Maaf para peserta sekalian, karena ada terkendala dengan laptop narasumber, jadi kami akan memindahkan materi ke laptop yang lainnya. Mohon ditunggu sebentar. Kami mohon maaf atas ketidaknyamanan ini. Terima kasih. Sorry.
No problem. Is it okay? Okay. Okay. Sorry. So once again, so I was saying, I want to talk a little bit about the impact of turbulent mixing on biogeochemical processes. So first, what is turbulent mixing? Turbulent mixing is just a random chaotic fluid motion, which is mixing fluid properties. So the fluid properties can be physical, temperature, salinity, but it can be as well biogeochemical, nutrients, plankton, etc. Okay, so often in the water column, you have a vertical variation with the depth of the properties. For instance, you can have variation in nutrients. Nutrients are generally, not always, but generally more depleted. There's less nutrients in the surface and more nutrients at depth. Whenever you have this turbulence, which is motion in any direction, it will generate a nutrient flux, a properties flux, for instance, here, which will be in the direction which is opposite to the gradient. So here in the upward direction, if you have more nutrients at the bottom, less nutrients at the top, then turbulent mixing will generate a nutrient flux upward.
Sorry. The slide is not moving. So I need to change this and do this again.
Maybe this one.
Okay.
Okay. For instance, if I change here. Okay. Okay.
Okay, go ahead.
Okay. Okay. So there will be a flux which will be whenever you have turbulence, there will be a flux which will be in the direction opposite to the natural variation of the properties. So here you have, once again, more nutrients at the bottom, less nutrients at the top. So the nutrient flux is upward. We often characterize the effect, the net effect of this turbulence, by a super diffusion coefficient, okay, which is called Kz sometimes, or K rho, unity meter square per second. And then you can compute the flux if you have the value of Kz simply by looking at the vertical variation of, for instance, here the nutrients with depth. Okay, if you have the Kz and you have different samples of nutrients at different depth, you can estimate the vertical fluxes, which is very important, for instance, for nutrient processes. There's exactly the same turbulence motion can generate as well physical flux properties. For instance, if you have, it's generally the case in the ocean, a temperature gradient, you have hotter water at the surface, colder water at the bottom, the same turbulence. So the temperature gradient, in this case, is going upward, okay? Then the heat flux is in the opposite direction, it's going downward. So it tends to bring heat to the bottom or cold to the surface. So every time you have turbulence, the fluid properties are mixed and it generates fluxes depending on the vertical variation of the properties. Okay, so when I first started in oceanography, one of the questions that was often asked to me is to estimate the nutrient fluxes in case of eutrophic waters, oligotrophic waters, oligotrophic oceans. So oligotrophic means there's really little nutrients, okay? So this is very clear water. And then when you have very little nutrients, the phytoplankton growth is limited by the nutrients availability. Typically, this is the schematic curve you have. If you look at, you have the depth, and you will see that the nutrients profile is very depleted, very few nutrients at the surface, and increasing nutrients where you're going at depth. Anytime you have turbulent motion, it tends to generate this upper flux of nutrients in the region, in the aphotic layer, which means the layer where you have enough light for plankton growth. So what is generally happen in this case is that the phytoplankton, so this is an example of measurement, look at the lower panel, an example of the chlorophyll, which is characterizing the plankton total biomass, tends to establish at some equilibrium depth between light availability and nutrient availability. So, and this plankton growth here will be really driven by the events of turbulent mixing, which sometimes can fuel a bit of nutrients in the aphotic layer, and you have this chlorophyll maximum appearing. So this is the case for oligotrophic waters. Now for eutrophic coastal oceans, like in the case here in Lampung Bay, most of the time there is no strong limitation of plankton growth by nutrients. Nutrients play a role, but there is not this drastic limitation as we can see in the open oligotrophic oceans. And plankton blooms not at subsurface, but rather in the surface mixed layer, very near the surface. Okay, so what is then the impact of stratification and turbulence on mixing and blooms in this case? So first of all, I would like to, maybe you know that if you're working in the oceans, I would like to remind what is water column, what I call water column stratification. What I call water column stratification is the variation with depth of the density. So here the right panel. In the tropical region, as we are here, so this is the red curve, what you see is that there is hotter temperature at the surface and decreasing with depth. The salinity profile is often a bit more complicated, but most of the time, most of the density is mostly controlled by the temperature. And you see lighter waters, less dense water at the surface, and denser water at the bottom, okay? Because the density depends on temperature and salinity. It decreases with temperature and increases with salinity, and the dominant effect here is often temperature, and you see that there is a decrease of density with depth. Okay. Okay, so why is it important for mixing? Why is it important for turbulent mixing? Because stratified waters are hard to mix. Okay, it's just a little bit of physics here, but it will not be very long. If the water column here, you have hot water at the surface, cold, heavy cold water at the bottom, and imagine you have managed to mix all these waters. You have homogeneous temperate water, let's say, throughout the water column. So the question is, which one has the largest potential energy between these two water columns? Well, in fact, when you mix stratified water column, you increase the potential energy. You increase the potential energy. Why that? Because if you look at the center of mass of the stratified water column, it is closer to the bottom because you have heavier heavier water at the bottom, so it tends to lower the center of mass of the water column. If you mix completely the waters, then you raise the center of mass of the water column, okay? Which means that it requires energy, so it consumes energy. So it is harder to, so it requires energy, so it's difficult to mix this water. So stratification is a natural barrier to mixing. Whenever you have stratification, you impede somehow the mixing, you limit the mixing, you limit the vertical motion, and you limit the fluxes of biochemical properties. What are the mixing energy sources? Where does the energy which is fueling the mixing is coming from when you have a water column? Well, most of the mixing comes from the surface. Okay, you have wind, you have surface waves, and you have buoyancy flux. What I call buoyancy flux is a loss of heat or increase of heat from the exchange with the atmosphere. So this is where you have the most mixing, and generally you have what we call a mixed layer, so a surface layer where the properties are completely mixed, are completely homogeneous. Okay, throughout I will call the depth, the extension of this mixed layer H mix. Okay, and in the mixed layer, generally, it's easy to make large eddies. You have a bit of wind, you generate large eddies which can grow up to the whites of the mixed layer. When you are in the stratified parts, as I tried to explain, it's harder to mix. Okay, so there is very generally much less mixing because there is less direct energy sources, and because you have this effect of stratification, which limits the extension of the eddies because it's hard to make an eddy. It has to fight against gravity, and it's more difficult to mix. Okay, you have still some energy sources in the stratified water column. There is no direct forcing by wind, but you have some physical object, what we call internal waves. I will not talk a lot about this, but we can generate a bit of mixing in the stratified parts. And finally, near the bottom, also often you have what we call a bottom boundary layer, because you have a variation of the currents very near the bottom. You have zero currents exactly at the bottom, and it increases a little bit above the bottom. And then again, you have another boundary layer, which is the bottom boundary layer, where often you have also well-mixed properties. Okay, and the energy of mixing comes from bottom velocity shear stress. So this is the variation of velocity near the bottom. Okay, so why do we matter about all these processes for plankton? This is what the main questions. So for phytoplankton blooms, the impact of physics has been discussed for now several decades, and one of the important hypotheses theory which came up is the Sverdrup's critical depth hypothesis. So when you have phytoplanktons, okay, if you have favorable conditions, enough light, enough nutrients, it will duplicate and grow, okay, until you can make maybe a bloom. Okay, so this is sometimes when sometimes you have a good light and nutrients, and all the time there is respiration, which end up to a constant death rate of the phytoplankton. So there is kind of competition between growth and death. If growth is larger than death, you have a bloom. If death is larger than growth, the bloom collapses. Okay. So for this theory, the Sverdrup theory, it makes several hypotheses. First hypothesis is say turbulence in the top mixed layer, so the homogeneous layer at the top, is relatively strong and really extend throughout the mixed layer. He also assumed that phytoplankton loss rate is constant. It's not necessarily true, it can vary in fact, but this is the hypothesis to make the theory. And he's also assumed that primary production, so the growth of phytoplankton, is not limited by nutrients, as opposed to the oligotrophic case. And finally, he also supposed that the daily photosynthetic of the plankton at depth Z is proportional to the depth. So he says basically that the production is exactly varying with the light availability. Okay, so what you see in this graphic is growth rate in green. Okay, so it varies with the light exponentially. You have larger growth rate at the surface and null growth rate when you go at depth because there is not enough light for the plankton to grow. And there is on the opposite a constant death rate, okay, which is symbolized here in red. So basically what we say is that there is a bloom if the rate is larger, the total rate integrated, so the surface, the green surface is larger than the red surface. If the green surface is larger than the red surface, you have a bloom. If the red surface becomes larger than the green surface, you have no blooms. So you see that this question is directly linked to the extension of H mix. If H mix is very large and the plankton is moving throughout this depth, this mixed layer, then the red surface will become larger than the green surface and the bloom will collapse. On the opposite, if H mix becomes slower, little, shorter, then you have very lot of more chance that the green surface, which characterizing the growth rates, become larger than the red surface. Okay, so basically in this theory, the dominant, very important parameters became simply the extension of the mixed layer. Okay, this is true if you assume all the hypotheses on the left. But within this theory, this is what happened. So okay, so if I schematize here what's going on, so you have a light gradient. When you are at depth, you don't have much light and the plankton cannot grow off. When you are near the surface, you have more light. What I schematized here is the extension of the mixed layer. So if the mixed layer is large, is smaller, shorter than some critical value, the critical depth, okay, the plankton is moving up and down, but in average, it has enough lights to grow and to overcome the depth rates. On the opposite, if the mixed layer becomes larger than the critical depth, in average, it doesn't have enough lights and the bloom collapses. This is why the extension and the mixing of this mixed layer depth is very important. So this is the theory. Yet, in the recent years, so this theory became very popular, very famous, and it was used to try to explain the blooms. But there has also been in the recent, in the past years, some observations which were not in agreement with this theory, and which points to the fact that the hypotheses made are probably too strong in some cases, at least. For instance, there has been some cases where the H mix, the depth layer was larger than the critical depth, and still they were observing some blooms. So one of the first hypotheses that was criticized is the fact that the turbulence was always strong in the mixed layer. In fact, this is not necessarily true. You can have a strong wind event, it generates a mixed layer, and just after the wind events, the waters remain mixed for some time, but there is no more turbulence, or there is only weak turbulence. Okay, and some algae, for instance, this is the case of dinoflagellates, or this is the case of cyanobacteria, have an ability to adjust their depth. Okay, for instance, the dinoflagellates, they have a flagella, so they can propel and try to find the optimum depth. Their propel ability is limited, so they have only very weak ability to move. So the question there is simply related to if the vertical speed of the algae, which is moving with its flagella, is larger than the vertical speed induced by the turbulence motion, then it will manage to reach its favorite depth and will bloom. On the opposite, if it does not, if the turbulence motion is larger, the vertical turbulence motion is larger than the vertical motion of the algae, then it wins, and then it is the algae is forced to move throughout the water, throughout the mixed layer, and you have no bloom because in this case, we considered that the mixed layer was larger than the critical depth. Okay, and this turbulence, the value of this turbulence motion is scaling with the like the vertical diffusion coefficient divided by the width of this mixed layer. So this is really depending. In fact, what I want to say is that only measuring the extension of the mixed layer is not enough. You also have to monitor somehow what is the intensity of turbulence. Okay, and only in this case you can be sure that really there will be bloom or no bloom depending on this condition. So mixed layer is different, mixed water is different than active mixing. This is one of the concepts that has emerged, okay? So only measuring with some device the extension of the mixed layer is maybe not enough if you want really to monitor the bloom, okay? So what came up is that there is a critical depth, but there is also a critical turbulence that can influence a bloom. Okay, and both of these matters. Okay, if there was only, critical depth, so here is a plot which is adapted from a publication, famous publication by Huisman. You have turbulent diffusion, which so this is basically a proxy. Reflects the importance of turbulent motions on the vertical axis, and you have the extension of the mixed layer on the horizontal axis, okay? And with this, you can, if you have only the critical depth as theory, it will only be bloom or no bloom depending on a critical value for the mixed layer, okay? But in fact, for the reason I explained, there is both a limit on critical depth and critical turbulence. And only you have no blooms only in the case where you have some critical depth when you have where you have overcomes the critical depth and overcomes a critical turbulence. And in this case, you have no bloom. On the opposite, you have a bloom. Okay. What was found as well is that the bloom can depend as well on the algae you are considering. For instance, in the more turbulent condition, a shallow water, maybe you have green algae, diatoms blooms, and if you have less turbulent water, more calm water, you may have more dinoflagellates or cyanobacteria. The difference between these two species being that dinoflagellates or cyanobacteria can, to some extent, adapt, try to move up and down in the water column. So just a few takeaway message for this part before I talk about that. Turbulence is generated by wind, currents, waves. Both active turbulence and mixed layer, they have controlled the bloom dynamics. And dinoflagellates are expected to dominate in weakly energetic environments or strongly stratified waters. This is something really important. Also, if there is some nutrient limitations, but turbulent mixing can also bring nutrients in the photic layer and sustain blooms. Okay, so this is for the oligotrophic part. But the three first points, I think, are the important points that have to be reminded when we are discussing blooms in coastal oligotrophic eutrophic waters. Okay. So the questions which come up is how we can estimate turbulent mixings. And it is something difficult because the turbulent scales are small. The spatial scales go from 1 meter to 1 centimeter. The time scales go from 10 seconds to 10 milliseconds. It's extremely challenging. Okay, this is one really important. This is a crucial parameter. It's really very clear for the recent past 20, 30 years that turbulence and physical processes are crucial if you want to really understand the bloom, but it's challenging. One way to measure turbulence is to use this kind of profilers, expensive profilers, which are more suited to, let's say, the deep ocean. Okay, it has several very high frequency sensors, but it's not really possible to use them in a shallow water like we want to do in Lampung Bay. Another way to estimate turbulence is to use some sensors. It's not less direct, less accurate, but you have, this is the water column. You can put the temperature, high frequency temperature sensors. And then when you have some mixing events, it will show on the time series as turbulent fluctuation. You see the high frequency motion and high frequency turbulent fluctuation. And then if you filter, you may, we did that previously, you may try to extract an information about turbulence. Another way is to use current measurements of the currents directly, the velocity. So for that we use acoustic Doppler current profiler. So the idea is that this profiler is that you send an acoustic waves. This acoustic waves is being reflected by all the particles that are in the waters. And if these particles move with the water velocity, for instance, I call U here, it will generate a shift in frequency, a shift in frequency. So you send the waves at frequency f, the wave is reflected and has with a frequency shift which depends on the velocity. So with the appropriate processing of this kind of measurements, you can estimate the profile, the velocity profile. Most of the time, these instruments are made to just have the average current profiles, but if you have some specific ADCPs which are very high frequency, and we own one in L'Océan that we want to install in Lampung Bay, you can resolve the turbulent spatial and temporal scales. Okay. Okay, so finally I come to the project on Lampung. So harmful algal blooms. Okay, so I talk about blooms. Some of these blooms have an impact, have a sanitary impact and economic impact, which are known as harmful algal blooms. These harmful algal blooms occurs generally in anthropized coastal waters or confined waters, okay, like the small enclosed bay where there is less water motion and there is more nutrients inputs from rivers and from all human activities around. They have important consequences. They can induce a loss of biodiversity. They have generate important economic losses for aquaculture and fishing because they generate important fish mortality. They can induce human poisoning. Okay, if you consume some this contaminated fish or shellfish, you can be ill. You can get sick. Why this has been spread now? These harmful algal blooms are seen all over the world because they have been spread. All this kind of plankton has been sprayed by the release from sea transport and the transport of shellfish, so from ballast waters and shellfish transfer. And of course, the proliferation is facilitated by the anthropization of the coast. Okay, and notably the anthropogenic pollution from rivers. What is the situation in Indonesia? Indonesia has a very vast maritime territory, as you know. There are thousands of islands. And so it is clear that the marine economy and the marine ecology is a crucial subject for Indonesia and for the government. And now for the last 10, 20 years, we have seen more and more harmful algal blooms occurring all over Indonesia. So this is just a few examples of a few of these blooms. Of course, we have some in Lampung Bay, which was caused by a species which is Margalephidinium polycricoid. This is the dinoflagellates. There has been a big bloom in 2012, sorry. There have been fish mortality in Jakarta Bay as well, in Ambon, in Ai Island in 2015. So all over Indonesia, we are seeing these blooms, which appears as coloration of the water column and which causes important death and economic losses. One of the species which is causing very much concerns is Margalephidinium polycricoid. This dinoflagellate called Margalephidinium polycricoid. It seems to be the dominant harmful algal bloom species in Lampung Bay for the past 10 years, and it is characterized by the following cycle. Okay, I speak under the. So I have a physical background, so I just. Try to simplify, but when there is a favorable condition, you have duplication of this phytoplankton. You have what we call vegetative growth in the water column. So it's increasing, duplicating, and you generate a bloom. When you have unfavorable conditions, there is not nutrients anymore, not enough nutrients anymore, or there has been bug turbulence, they don't have enough light, or another species becomes dominant. Then they go for sexual reproduction and encystment. So they generate cysts which are buried in the sediments, and these cysts can stay there for months or years. And this is one of the reasons which why this kind of species is very hard to get rid of, is because it can, even if you have no bloom, apparently the water are clear, but it can stay in the sediment, patiently waiting for more favorable conditions to re-emerge in the water column. Okay, and this were favorable condition. They can be an impact of the turbulence, because the bottom turbulence can manage to resuspend this cyst in the water column. And if then the conditions are favorable, there is good light, there's good nutrients, they grow again and start another cycle. So there has been investigation of this species in the Lampung Bay. Okay, this is a paper. This is extract from a paper by Toa et al. and co-workers, which imply notably researchers from Marbeck and the BBPBL. And so, what is denoted on this map, extract from this publication, you have in black. The black circles represent the places where there has been detected Margallifinium polycrocoids within the sediments, and in yellow, within the water column. Okay. Yes, and there has been many blooms of this species since 2012, which was a big bloom, which was responsible for high mortality. Looking at the anthropic activities in the bay, there are several anthropic activities we can favor these blooms. Of course, there is a lot of water discharge near the Bandar Lampung, and there has also been a lot of ballast water discharge in the orange area, so which may explain why we have been import this new dinoflagellate species in the region. And there are also some aquaculture activities which can also release some nutrients in the water columns, or shrimp farms, fish farms, which can also favor the appearance of these blooms. What are the factors driving such a blooms in Lampung Bay, and not only in Lampung Bay? In fact, I say in Lampung Bay, but more generally in Anthropized Bay. This is some hypotheses that we put, is that the following factors could trigger such blooms in Lampung Bay, or the following sequence. Okay, we have first bottom turbulence. You have bottom turbulence, so you are able to resuspend some skids which were buried in the first few centimeters of the sediment. Maybe you have heavy rains, which can help to generate high nutrients inputs from watershed. Okay, not well, and then you have successively some calm weather, hot weather. It's always a bit hot weather here, but some calm weather condition, which ensures a re-stratification of the water column. Okay, if you remember what I said previously, when you have a stratification of the water column, is that it means that the density will decreasing from the surface to the bottom, and temperature will be increasing, from the surface to the bottom, and temperature will be decreasing from the surface to the bottom. So you have this vertical variation of the physical properties of the water column, which ensures its stability and which impedes mixing. And when there is little mixing, the dinoflagellates like that, because they can really manage with their to establish that their preferred depths generally near the surface. And then maybe this blooms ends because there has been some more turbulence that is perturbating the dinoflagellates, or there is simply not enough nutrients anymore because they have eaten all the nutrients. Okay, so we can imagine these following cycles, but this is really hypothetical for the moment. This is really a conjecture. So based on these conjectures, we wanted to build a project, a multidisciplinary project Paladin, which is implying so the BBPBL and the l'Océan, and which was for the moment funded by French funds from the CNRS, climate change, the Institute French Indonesia, the IRD, the Institute of Research and Development. So the idea of this project is to really monitor with a mooring the water column, having both some high frequency physical measurements from currents, temperature, salinity, to know the stratification as well, and some biochemical sensors as well for fluorescence, which will be complemented by the essential water sampling, which is made regularly by the BBPL, okay, which determines precisely what is the species and what is the species dominating, what is the real exact concentration. Okay, so both are essential, and so we could want to make a kind of sentinel site here in the Lampung Bay, the Tahun Bay, to really understand what sequence is really favorable for the emergence of a bloom. In the long term, in fine, we could develop an harmful algal bloom risk index, which will be useful for all the local actors, okay, for aquaculture, maybe tourism, whatever. So this is really about these games. We have this very new measurements. New measurements will be very high frequency measurements. I think this is really seldom done because it is you have very few examples all over the world where you can gather very exact sampling of phytoplankton, which is made regularly, very high frequency measurements of the temperature and extraction of turbulent properties. This is something which is really not done often, and this is something really new. And so from all this knowledge, we'll build first some scientific knowledge. Okay, I'm a researcher, so the basics we want to do altogether is to first get some scientific knowledge, understand how it works. And once we understand, we can build some, based on statistical models and modeling models, harmful algal bloom risk index, and which will help the risk mitigation. Okay, this maybe we could say, okay, after the sequence we add here, there is a strong risk for harmful algal blooms, so be careful. Okay, and we will, thanks to the strong entourage of the BBPBL in the region, we can also have some ground knowledge feedback to know if it is that works, what we just say is working or not, and this is also very important. Okay, I think I know Mrs. Moana is often going throughout the bay to see what were the impact of the harmful algal blooms, and is giving advices to the aquacultures, farmers to adapt the position, for instance, of their cages. All this is very important to know if the practical, theoretical projection we made can be have an impact on the ground. So this is the mooring design we want to do. I don't know if you can see clearly it. So we want basically to install a mooring near this small BPBBL cages in front of Lampung Bay, in the Huron Bay. I don't know if yes, sorry, maybe I should have shown. This is Huron Bay is here, for those who don't know it. It's in the Lampung Bay, and this is the small inner bay within the red circle. So in this Huron Bay, this is a shallow water bay, like from 12 to 15 meter depth, we will install this mooring where we'll have some very specific physical sensors. So we'll have some high frequency temperature sensors at 1 Hertz, some very high frequency temperature sensors, which will be at 8 Hertz, some more classical CTD sensors measuring temperature, salinity, and pressure, and as well some fluorescence and turbidity sensors near the surface where generally the blooms occur. In conjunction with that, in complement with that, we'll have the ADCP, the very high frequency ADCP, which will profile the water column and the high frequency currents. Okay, and once we get all the data, we will also want our project is also to transmit in real time all this information. Okay, so once we have so maybe we can better monitor and monitor live the occurrence of this bloom. So very important for the moment. We have purchased the material. Almost everything is here, waiting at our lab. But for the moment, this has not been installed yet in Lampung Bay for several reasons. First, there has been the COVID-19 pandemic, which has, of course, restricts the possibility to come here. And we are also waiting for now. We will now apply to research permits. And we're also looking for the appropriate way to send instrument and clear the customs. So all this, once we clear all this problem, we want to install probably near the autumn of this year, this complete mooring in the Huron Bay, Lampung Bay. Yet we still have some data already collected since 2020, which were, for instance, some weekly subsurface plankton sampling in Huron Bay by the BPBL. So this has been very intensive sampling every week and every species of phytoplankton. So I'm not using all this data for the moment, but we are not using all the data for the moment, but there has been at 3 sites, the 1, 2, 3 here, and there has been a few sensors that we managed to send before the pandemic, RBR sensors, which are high frequency temperature sensors. So there is plankton center. There is also water quality sampling, so nutrients, oxygen, pH, and hydrology at the subsurface, temperature, salinity on these 3 sites. There is also the fish mortality survey by the BPPN in Huron Bays and surroundings. And finally, there is also some free data for the moment from the meteorological buoy, Japanese buoy. Okay, and this is the picture below is the temperature sensor that has been set up here, deployed by the PBL technician. So this is the estimates of losses impact on fishes from the gross estimate, just to summarize, from Mrs. Moana. So there has been several impacts in Huron Bay. Okay, this small, very small inner bay, in Pascasarjana Island in front of Bandar Lampung, and in Ratai Bay as well. And all this has caused important fishes, loss of fishes in 2020. There has been less in 2021, I think. I focused here on my analysis on 2020. Okay, so this is the report on the global survey of loss, which were caused by mostly by harmful algal blooms. So I focused here in Huron Bay, where we have the most regular survey and sampling of the water quality, phytoplankton, and where we have the RBR sensors. So the upper panel, you see in the upper panel, I plotted in blue the total dinoflagellates species, every kind. In orange, brown, the Margalefidinium species, which is the most problematic species, which seems to be the most problematic species now. And in green, I plotted the total diatoms concentrations from any kind of diatoms, okay? Just to see what were the dominant ones depending on the time. Because, you know, as discussed previously, they have some kind of opposite behavior between dinoflagellates, which rather prefer calm waters. When we have more turbulence, you would expect diatoms to dominate. Okay, the letters on the upper panels symbolize the seasons. So NWM is northwest monsoon, okay, which occurs from roughly December to February. The SEM is the southeast monsoon, which more or less dry season, where you have less rain, less wind, but you can have some upwelling. And in between, we have the transition from northwest to southeast monsoon, or the transition from southeast monsoon to northwest monsoon. Okay. Be careful that the scale on the vertical axis is logarithmic. Okay, so it means that it is multiplied each time. Here you go from 1 to 10 to 100 to 1,000 to 10,000, 1 million, etc. So it's increasing very fast with the ordinates. What we can see is that you had, for instance, a strong bloom occurring in early March in Huron Bay. And when you had these strong blooms, really, it was really caused completely by Margalefidinium, which will then represent increase to very, very high level concentration of cell per liters, and really completely dominates the phytoplankton distribution. It was really, you see that almost all the dinoflagellates, if you in proportion, were almost all Margalefidinium and were much higher than diatomy. We can, I see this, that Iguana computed a diversity index, which I think was a good idea, so I tried to do it myself as well. Diversity index is try to represent how much biodiversity you have among the algae, among the phytoplanktons. So if you have a strongly dominate one, you have the diversity index, which is collapsing. And if you have many species and equal repartition between these different species, you have a larger Shannon index. So we see that this Shannon index was dropping when we had this bloom. And in fact, it even goes near to 0, I think, here. So in summary, we have, it seems that we have, for this 2020 years, we have diatomid, which seems to dominate during northwest monsoon. Okay, here and here, the green curves is above the other ones. And we have dinoflagellates, which dominates during the transition from northwest monsoon to southeast monsoon. The strongest arc-fungal algal blooms were caused by Margalifidinium and induced a drop in the diversity index. Okay, so this is what we see. So what were the environmental conditions? Sorry for this plot is a bit busy, but I will try to describe it step by step. So in the upper panel, what you see is the temperature and salinity. Okay, so with the dashed lines is the weekly, more or less weekly monitoring. And I have also overlay the partial monitoring by the RBR sensors at 1 meter. So it is at the surface, so it's monitoring. Okay. And you see that there you have some kind of increase of temperature, small increase of temperature at the surface in the transition season, and then decrease in the northwest monsoon season. On the second panel, what you see is the wind in red and the precipitations, the rain in blue. Okay. So this has been smoothed down because I have applied a moving average, 1 week moving average, so that we can better see the global fluctuations. And what we see is that we have some heavy rains going near the end of the northwest monsoon season, at the beginning of the following northwest monsoon season. We have also stronger winds in the northwest monsoon season. Okay. Finally, the third panel is the nutrient concentrations. So from all the nitrogen nutrients with N, which are in blue, orange, green, and from the phosphate nutrients, which is in red. Okay. And finally, the last panel is the two main class of phytoplankton, so dinoflagellates and diatomy. So if I look at this big peak which occurs in Oran Bay, maybe we can hypothesize that there has been some strong wind periods followed by relatively calm conditions. So you have a strong winds lasting for a few weeks, then relatively weak winds following. There has been some nitrogen inputs, maybe by the rain here. And then we had this strong algal blooms occurring in early March. There has been a second, later in the year, in late April, there has been a second harmful algal bloom of dinoflagellates, which was following this kind of relatively different condition, and the wind was remained relatively calm, but we see that there is a big phosphate peak and always a calm condition, and there has been a peak as well, again, of dinoflagellates here. Well, this is the very first analysis. Huh? We don't have the full mooring, so just try to analyze the data we have. I tried to make analysis using statistical method. Maybe those who doing ecology are familiar with that. This was the first time I was using it, and it's not that current in that we don't use it so much in physical oceanography. But the goal is to describe the variability of the complex data set using a reduced number of axes of variability. So this is often the case when you are looking at ecology and biogeochemical techniques. You have a lot of variables. You have many nutrients, you have the phytoplankton species, you have the environmental condition, wind, rain, etc., etc. And so if you start to look at correlation one by one, it becomes very, very complicated to have a global picture. Okay. So what is the principal component analysis is doing is that it will represent the different variables in a plane. And basically, the interpretation is that, for instance, here is just kind of you can have a kind of fast geometrical interpretation. For instance, you see that variable one, variable two will be correlated, variable 3 and variable 4 will be correlated, and these variables will be anti-correlated with these 1 and 2 will be anti-correlated with 3 and 4, and finally, the fifth variable here is just orthogonal to the other one, which means it's not correlated at all, positively or negatively. Okay, so I tried to do that for the variables we had for the dinoflagellates. So it is very preliminary. So we see that the data is spreading along more or less 2 axes. sorry, the labels are a little bit small. So the green circle represents the dinoflagellates variable, okay, because it's hard to read. But what we see here is that we have increase of rain, increase of wind during the northwest monsoon, and this is associated with an increase of ammonia, a decrease in phosphate, a decrease in temperature, a decrease in salinity. Yet, and this is a bit disappointing, this does not seem, with this simple first analysis, we don't see the direct impact on dinoflagellates because the axis represents dinoflagellates is more or less orthogonal to this axis. Okay. On the otherwise, we see that the dinoflagellates seems to increase here with some other nitrogen inputs, NO3, NO2, NO3N, and O2N. Okay, and the color scale, sorry, is the season. So we see, once again, we see, for instance, that you have strong rain and NH3 inputs during the rainy northwest monsoon, and that once again you recover that the dinoflagellates occurs during the transition season. We can do the same for the diatome, and for the diatome, you can have the same conclusion for the physical. We see that the wind and rain is associated with northwest monsoon and is correlates with the nitrogen inputs. But you see that you have also a small input, small impact of the wind, which seems to favor the diatome, okay, which somewhat confirms that the diatome has more fitted to turbulent conditions that could be induced by the wind. Okay, so I go back to this plot here, and I want just to finish to make a small focus on the second harmful algal blooms that was occurring in late April in Huron Bay, which was generated by over calm conditions. So I look at these plots, I zoom on this period, okay. So going from a period here of over 30 days, here, roughly 1 month, the April month, you see here the April month. So the axis is days of 2020 is but it's the month of April. And what we see here are the temperature sensors fluctuation that were recorded by the RBR at 3 depths, near surface 1 meter, then 7 meter, then near the bottom at 14 meter. What we see, and the green axis is the dinoflagellate concentration, again in log scale, so which is strongly peaking, okay, from 1 week to another. What we see, which is appearing very clearly, is the daily fluctuation. You see that there is a peak of temperature at the surface every 24 hours. So you expect this when you have relatively calm condition. Why? Because during the day, the water is heating, temperature is increasing. During the night, there is a cooling, and you have natural convection, which is mixing the water. Okay, so, and this is what we see, for instance, here. So what is interesting here, and this is relatively, when I look at all the RBR sensor data that we have, it is not often occurring that often, is that for several days, for 5-6 days, we have a stratification which remains stable, What I mean here is that the temperature at the surface remains hotter than the temperature at mid-depth, and remains hotter than the temperature at the bottom. So there is variation of temperature with depth, so there is stratification. So it means here that the water remains stable, okay, which could have favored very little mixing and very conditions favorable to this second dinoflagellate bloom to occur. Okay, and for instance, just I was citing one recent study in the Korean waters by Lim et al. In 2021, which shows that stratification was probably one of the dominant one of the dominant factors to explain the bloom. Okay, and because often in some publication you can see that it's temperature. Sometimes temperature can favor some blooms below some value, but in fact, when you have an increase in temperature, often it is associated with an increase in stratification, and this is mostly the increase of stratification which is important. So I come to the conclusions. We have important impact of harmful algal blooms on fish mortalities. So maybe if I didn't get roughly at least 500 million rupiahs right, in 2020 in the Lampung area, which have, and this does not mention the possible touristic impact. This is only the cost for basic cost for fishes loss. These harmful algal blooms were dominated by the Margellifidinium polychloride dinoflagellates. For what we see in 2020 is that the dinoflagellate dominated during the transition season, where diatome dominated during the northwest monsoon. The strongest harmful algal blooms seems to have followed a sequence of high winds and then calm conditions. So maybe we had some resuspension of cyst and then good condition with turbulence to establish a bloom. The statistical PCA only managed for the moment to extract dependence on nitrogen inputs, but this is not enough for sure. We need to include turbulence stratification as variables in this analysis. So for the moment, we don't have continuous series, so it's a bit difficult, but with the mooring to come, we know we will have these variables and this will be very interesting. What is sure, though, what strikes me is that what strikes us is that these shallow coastal waters, the environmental conditions evolve very fast. Okay, so from one day to another, you can have complete mixing of the water column. You can have restratification. You can have a bloom occurring from one day to another, almost. So it's really the concentration can increase very fast. So it really points to the fact that you need both long-term monitoring to see all the possible environmental conditions, but also high-frequency monitoring if you want to be able to resolve these processes. And this is really what we want to propose in the Palanam project to help to tackle the dominant physical forcing, as I explained, that dominates the turbulence in the water column. In the mid-long term, after we collect the data, we process the data, we make some statistical analysis, maybe we make some dynamical models, maybe we will build a robust harmful algal blooms index based on pre-existing conditions, so what were and possibly meteorological forecast. So to this end, we will have to use based on the strong physics to describe the water column, but also statistical modeling to really try to clear and to extract what are the main most important parameters, but also maybe some more deterministic approach. I mean, biogeochemical, hydrodynamical coupling. This is something we have the knowledge for which we have some knowledge at L'Ocean and which might be developed along the years. Well, that's all, and thank you very much for your attention. Apologize for the difficult beginning with the microphone, etc. But and thanks again for the invitation. I hope it was not too long. Sorry.
Thank you. Thank you very much for very insightful about how to monitoring the algae blooming. Is my voice can be heard? Kedengaran nggak ya? Okay. Saya rasa let me explain to them in bahasa Indonesia first.
Okay.
Barusan sudah disampaikan in konklusi bahwa sebenarnya apa yang menjadi masalah dengan Teluk Hurun adalah adanya blooming alga, yaitu dari, mana catatan saya? Dari apa ya Bu Ana? Dari dinoflagellata. Nah, kemudian kalau kita lihat secara ekonomi itu sangat merugikan sekali, hampir miliaran ya Bu Ana ya, yang diantaranya salah satunya adalah banyaknya kobia yang mati akibat alga blooming ini. Beliau juga menyampaikan ada hal yang harus kita lakukan, diantaranya adalah melakukan HAB warning index yang bisa dilakukan dengan cara memfasilitasi dengan adanya pemasangan sensor dan lain sebagainya. Tadi secara tidak langsung kami sudah diskusi dengan beliau, rupanya ini perlu ada kerjasama di antara kita semua untuk dapat memonitoring kondisi perairan, terutama di perairan dangkal seperti di Teluk Hurun dan lain sebagainya. Beberapa hal yang mungkin nanti bisa disampaikan nanti kami akan coba untuk memfasilitasi Bapak dan Ibu sekalian seandainya menginginkan materi dan sebagainya. Baik, kita mulai saja dengan pertanyaan atau diskusi yang ingin disampaikan. Di sini dari chat box ada Pak Yosep atau Mas Yosep ya, kalau Pak terlalu tua mungkin ya, menyampaikan bahwa have any, there's one question. Sorry. Okay. There's have a question in the chat book.
Okay.
Nitrogen and phosphate content, if that any relationship between those two conditions would have, you can read that.
Ambil.
Yes, yes. Of course, it is the basis for the occurrence of. So when you have if there was no eutrophication of water, whatever will be the condition, physical condition, the turbulence, whatever, certification, for sure there will be. This is the basic fuel of the harmful organisms. And actually, we see that there are some correlations with the use of nitrogen. Unmute. Yes. Okay. Okay. Yes. Sorry, I don't know if you heard me first, but yes, of course, there is a very clear relationship with the recent eutrophication of anthropized bay, and notably Lampung Bay, and the occurrence of these harmful algal blooms. The question is now that we know that there is, regarding nutrients, we have enough nutrients to sustain blooms, and the next question
Badanku buka. Mana alat bukanya?
Okay. Hold on.
Okay.
Bapak dan Ibu sekalian, tolong di mute ya. Okay, go ahead.
Okay, I go. Okay, sorry. Okay, so once again, to the question of Josep, yes, he was asking whether the harmful algal blooms have any relationship with eutrophication. And there is a definitive relationship between harmful algal bloom and eutrophication. This is really the basis of the eutrophication is like the necessary condition to have harmful algal blooms to occur. If there was no eutrophication, no high nutrients inputs, will be clear of harmful algal blooms, whatever will be the physical conditions. Now the question is that when you have the necessary condition regarding there is strong nutrients inputs, for instance, Lampung Bay or Jakarta Bay, from all the human activities. Now, when you have these strong nutrients inputs, the question is how the physical condition will monitor, will drive, will select which species will dominate. For instance, between diatomaceae or dinoflagellates. We know that and the idea I tried to explain was to say that if you have a calm, very strong stratified water column, then the dinoflagellates, which can be potentially harmful, will dominate over the diatoms. And when we have more turbulence, and this will be the diatom that will dominate. Okay, but for sure there is a clear relationship between the nutrients and eutrophication nutrients and harmful algal blooms. This is a kind of necessary condition. Once you have these necessary conditions, you try to start to think what are the physical interaction, the physical forcing that will select one species or another. But this is a complex process, and this is why we need to have very fine monitoring
and deep analysis afterwards, because this is a very complex process, very complex interaction between the nutrients inputs, the light availability, which is changed by the turbulent mixing. So, yeah, this is all the question. But yes, the basic answer is yes, of course.
Okay, thank you. Thank you. Kedengaran ya suaranya? Kedengar suaranya? Oke. Baik. Audiens yang secara offline ada pertanyaan? Jika dari audiens yang secara offline ada pertanyaan, silakan. Ya, silakan. Minta Mas. Ada ini lagi nggak? Ini bisa dipakai.
Thank you, Mr. My name is Ayuan and I'm from the Minister of Public Administration. The subject is really interesting for me because it's kind of new for me about the HAV, and I want to ask you about if this topic is really important. Is there any discussion with the government of Lampung, especially the mungkin Ibu bisa bantu Dinas Kelautan dan Perikanan, apakah sudah ada diskusi terbuka terkait hal ini, karena ini termasuk masalah yang cukup serius. Kalau misalnya memang ini bisa diangkat ke Dinas Perikanan, saya rasa ini akan mampu memperbaiki reformasinya, terutama di bagian Lampung.
So it's a problem with the HAB. It's very seriously. Is there any discussion with the agency, like what you call it, from with the Ministry of the Fishery and Marine and Fishery?
Yes. Sorry, maybe because I was a little bit confused at the beginning of the talk with the technical problems, but yes, this project is built up with the BVPBL, which is a laboratory, a structure which is under the KKP, so the Ministry of Fisheries and Aquaculture. So clearly it is implicated in the project, and yes, and of course this is a question which is of major importance for them. So we have a formal agreement with this ministry, and so this project is built under this agreement. So
sebenarnya ini sudah bagian dari diskusi bersama dengan Balai Budidaya Laut. Nah, itu kalau misalnya kita bicarakan itu sudah bagian dari Kementerian Perikanan, dan biasanya kalau sudah bagian dari Kementerian Perikanan itu akan terkait juga dengan Dinas Perikanan dan Kelautan. Itu ya Bu Ana ya, sudah ada diskusi dengan Dinas Kelautan dan Perikanan ya.
Untuk perbaikan ekonomi ya, karena kalau secara kalau informasi monitoring lalu kami disampaikan ke kalau ini tidak ada, tapi kalau untuk terkait kebijakan belum tahu.
Jadi sudah mungkin saya sampaikan lagi ya, jadi sudah didiskusikan terkait dengan monitoring yang ada di Teluk Kurun. Tidak hanya Teluk Kurun ya Bu Ana ya, jadi di Teluk Lampung secara keseluruhan. Namun untuk perubahan policy yang diberikan oleh Dinas Kelautan dan Perikanan dari Provinsi Lampung itu kita belum tahu ya, tapi ini sudah dibicarakan secara nasional di Kementerian. Cukup? Baik. Anyone else? Ada lagi? Ayo, ini cukup sangat menarik ya terkait dengan HAB ya. Jadi banyak faktor yang mempengaruhi, dan sebenarnya tujuan dari sama Pak saja ya. Tujuan dari Pak Yanis ini adalah bekerja sama dengan kita untuk memonitoring kondisi yang terjadi dengan HAB itu adalah berfluktuasi tergantung dengan berbagai faktor tadi. Tidak hanya faktor biologi, faktor kimia, dan juga faktor-faktor lainnya, faktor fisik dan lain sebagainya. Dan yang menjadi catatan adalah bahwa dinoflagellata ini mampu untuk membentuk kista. Jadi kista ini artinya kita tidak akan bisa mematikan ya, menghentikan mereka untuk booming. Jadi kista ini akan bertahan di dasar dan itu juga akan terpengaruhi oleh berbagai faktor. Sehingga proses monitoring itu sangat diperlukan untuk kelangsungan dari budidaya aquaculture. Gitu ya Bu Ana ya? Perlu penegasan. Saya perlu penegasan untuk itu. Jadi intinya adalah monitoring itu perlu dilakukan setiap saat. Jadi monitoring tidak selalu harus setiap detik, setiap menit, tapi dalam hari atau minggu dan juga bisa dilakukan. Karena ini yang sudah dilakukan di tahun 2022. I was explain them that you have been doing the monitoring since 2020 about the condition. Yeah, true. Working together with Ana since 2020, and this is monitoring is really needed in order to.
Yes.
Yeah, in
Definitely.
order to manage all the marine ecosystem, particularly in coastal area. Ada lagi pertanyaan? Ya, silakan. One more question.
Thank you for the time and opportunity you've given to me for the introduction myself. I'm going to use the degree student in biology, faculty of Mathematics and Natural Science. I want to ask question. Why is harmful algal bloom can be dangerous to the ocean? And is there any way to control or manage the bloom and to protect it?
Why is HAP is very dangerous for the aquaculture, and how to manage, how to control the HAP, how to control the harmful algal bloom?
Okay, why is it dangerous? Is that well, it's basically killing fishes, so it's have an economic impact first, and there is a risk. I'm not ecological expert, but there is also a risk of if you consume the contaminated fish to get poisoned. So it's a real problem. Now, how to control that? You cannot really control, of course, the physical environmental parameters, which are temperature certification, wind, tides. You just they are there. You cannot. It's almost impossible to control them. What you can control is what you can act on. What public policy can act on is on the rejection from the drivers. So they try to filter the water discharge. So there is less nutrients inputs in the region. That is what you can do. And then maybe I think this is something you can try to do. Is more like try to avoid big losses of fishes by, for instance, moving. This is what, for instance, our partner and BPBL are doing, are advising sometimes to move the cages up and down the water column, for instance, because the blooms often occurs really near the surface. So if you deepen a bit the cages, maybe you can avoid fish mortality, fish contaminations. So basically, but this is just, trying to heal the symptoms. If you want to heal really the disease, let's say, you really need to monitor the discharges and the eutrophication, what we call eutrophication, that is the input of nutrients. For the global, of course, for the global condition, meteorological condition, yes, you can only, yes, they are there, and you can do nothing, really not much about that. There is also a risk with climate change that there is more and more, maybe more and more hotter temperatures, stratified waters. But this, of course, is a global trend. You can do not act locally. You cannot do much about it, except yes, you have to work with maybe public governments to try to to try to limit nutrients inputs and maybe warn the population about the risk as well, because some people do not know the risk, so maybe they will consume fish that has been contaminated. And that's all. I think this is the main thing you can do. And hopefully in the future, if we have some harmful algal bloom risk index, maybe you can warn globally, say, okay, be careful. There is a bloom which will comes up. So be careful for your fishes, your cages. Be careful if you want to consume them. Be careful, maybe even if you want to bath, or to swim, etc.
Sudah paham atau yang penting adalah di sini bahwa kita tidak bisa mengontrol kondisi lingkungan, tapi kita bisa melakukan dengan cara memonitoring kondisi yang ada. Dari sejak itu nanti dari hasil tersebut nanti bisa kita usulkan atau kita memberikan saran apa yang harus dilakukan dalam proses dalam dunia atau misalnya ya, kalau pas lagi ini diprediksi akan blooming misalnya, ya sudah kita sarankan untuk beberapa misalnya lewat budidaya laut untuk menyarankan pada nelayan atau juga nelayan misalnya ya, untuk budidaya untuk tidak melakukan budidaya ikan-ikan tertentu. Ini hanya merupakan suatu manajemen awal untuk melihat memprediksi apa yang akan terjadi. Itu menjawab juga pertanyaan pada Tamu. Silakan. Oke, ini ada di sini atau ada di secara online. Baik, berikutnya there's a question also from Joseph. You can read to the do I have to read it for you?
This one you mean about the PCA?
Yeah, it's about the PCA.
Yes, a question from Joseph on the chat is asked whether the variation of PC1 PC2 is around 50%, prediction is below 50, or maybe no, yes, no, it's just around 50%. Maybe I made a typo on the text, but yes, the prediction of the first two principal component analyses that I shown the plots. With this first two component analysis, you reproduce 50% of the variability. Yes, so just that's it. Yeah, no. So maybe if I put a typo on the text at some point, but no, that's it. You understand correctly. It's around 50% that were explained by PC1 and PC2. I think there was maybe one question about the temperature.
Yeah, I have already
answer.
Include the explanation that you have done for the other audience.
Okay.
Okay. Dari online ada yang mau menyampaikan diskusi atau ingin bertanya? Dari online. Mas, dari online. Baik, sambil menunggu, ada lagi secara offline? Sudah paham atau sudah paham betul ya? Antara sudah paham dengan sudah paham betul ya? Apa namanya? Kita sampai jam berapa? Baik. Jika tidak ada pertanyaan kembali dari audiens, saya akan menyampaikan beberapa hal. Yang disampaikan oleh Dr. Yanis adalah bahwa turbulence, kemudian curah hujan, kemudian kondisi perairan, yang termasuk dalam stratifikasi di antara itu sendiri, yang dipengaruhi oleh berbagai faktor, di antaranya suhu dan lain sebagainya, itu akan mempengaruhi blooming objek. Itu perlu dilakukan suatu monitoring untuk bisa memprediksi seperti apa yang sebaiknya bisa dilakukan di dalam aquaculture. Kemudian ada proyek kerjasama yang bersifat multidisipliner yang disampaikan oleh yaitu untuk memonitoring kondisi perairan tersebut nanti itu akan disimulasikan sedemikian rupa sehingga hasilnya bisa kita dapatkan untuk saran-saran yang bisa disampaikan untuk para pembudidaya. Kemudian saya mengambil catatan dari beliau. Ada yang pertama adalah turbulen itu terbentuk karena adanya arus dan juga adanya aliran angin. Kemudian turbulen juga merupakan suatu kondisi yang dinamik ya, antara kedalaman dan juga dengan berbagai faktor, diantaranya tadi adalah faktor. Maaf, suara saya nggak kedengaran. Oh, maaf. Can I use? Baik, maaf, saya ulangi sekali lagi. Ada beberapa hal yang ingin disampaikan oleh oleh Dr. Yanis Cooper. Di antaranya adalah bahwa pertumbuhan dari hub itu akan dipengaruhi oleh turbulence itu sendiri. Kemudian di samping turbulence juga heavy rain atau curah hujan ini. Di samping itu restratifikasi dari perairan juga sangat mempengaruhi terhadap kemunculan dari hub. Di samping itu juga Dr. Yanis juga menyarankan untuk adanya karena sekarang ini sudah dibentuk kerjasama dengan merupakan suatu proyek multidisiplin, yaitu dengan mengadakan suatu proyek yang disebut dengan Palhadin. Nah, dengan Palhadin ini merupakan suatu kerjasama dengan memonitoring kondisi perairan dengan menggunakan sensor. Cuma kendalanya dari hasil diskusi kami bersama, kendalanya adalah alat-alat tersebut, sensor tersebut tidak mudah masuk ke Indonesia, terutama ke Provinsi Lampung. Jadi ada kendala yang perlu kita cari solusinya. Baik, saya rasa any question about your presentation, is that possible to share with them, to share with the audience?
Yes.
Oke. Baik, Bapak dan Ibu sekalian dan juga adik-adik sekalian yang ada di secara mengikuti kuliah tamu ini secara offline. Dr. Yanis Cooper bersedia untuk sharing PPT-nya. Jadi nanti kita akan sharing. Kemudian di samping itu, jika Bapak dan Ibu sekalian dan juga adik-adik sekalian masih ada pertanyaan terkait monitoring kondisi lingkungan perairan dangkal di Teluk Gurun ataupun di Teluk Lampung ataupun di tempat yang lainnya, bisa dilakukan untuk bisa berdiskusi bersama dengan Dr. Yanis. Do you have any email that that people can contact with you?
Yes.
Ya. Saya barusan minta email beliau untuk bisa dilihat di chat room, email yang bisa digunakan untuk berdiskusi terkait dengan monitoring kondisi perairan. Jika tidak ada lagi pertanyaan, saya akan tutup di sini dan saya akan kembalikan ke bawa acara. Saya mohon maaf jika ada kesalahan dan lain sebagainya, dan mohon maaf juga atas technical problem yang kita hadapi pada saat awal dari kuliah tamu ini atau kuliah tamu ini ya. Terima kasih sekali lagi, saya mohon maaf, mohon ampun saya panjat kepada Allah. Wassalamualaikum warahmatullahi wabarakatuh.
Selanjutnya adalah penyerahan sertifikat
Oke, baiklah Bapak Ibu hadirin yang hadir secara offline maupun secara online. Demikianlah rangkaian acara kuliah tamu kita pada pagi hari ini. Terima kasih atas segala perhatian. Mohon maaf atas segala kekurangan. Saya akhiri, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.